All right, so I'm going to try to do 2.6 number 8 again, but this time I'm going to get the problem that's out of your guys' version of the textbook. So they're asking me, what are L and D? And they're telling me that D is the diagonal pivot matrix. For this matrix A. And they tell me that A is 2, 4, 8, 0, 3, 9, 0, 0, 7. And they're saying, what's U in A equals LU, right? And what's the new U in A equals LDU? Okay, and they notice that A is kind of already triangular, right? Let's see, and I have the right thing. This is the problem you guys are working on? Yes? No? Maybe?
Yeah. Yep.
Okay. All right, so first things first, let's answer this. What's U in the LU decomposition? Oops, A is a terrible choice, Joe. Okay, so in the case that I need to decompose A here into a lower triangular matrix times an upper triangular matrix, right? So what's a convenient lower triangular matrix for this? Well, so I don't know. That's already an upper triangular matrix, right? Okay, so what's the lower triangular matrix that goes with it? Like if I just need to write this as something that only has stuff in here, maybe let me mark the zeros. So here's the kind of skeleton of a lower triangular matrix. And then I need to multiply this by something that's the skeleton of an upper triangular matrix, so like this. And I'm supposed to see this guy? Well, I mean, that thing's already upper triangular, right? So the upper triangular matrix could just be this one, right? So I can just put my 2, 4, 8, 3, 9, and 7 in there. And then what does that make the lower triangular matrix in order to make this true?
Seven, 9, 3, 8, 4, 2.
7, 9, 3. Oh, I see. You're kind of transposing?
Yeah, I'm not really up to this section yet, so I was just throwing something at it.
No, I appreciate that. That's good. So had we multiplied that matrix times this one, we wouldn't get back our matrix A. So really here, right, what I'm asking is L times U is supposed to be this thing. So what's special about this is that this thing I'm supposed to get is one of those two items, right? You guys see that? So what matrix do you multiply by another matrix to get back to where you kind of started?
The identity matrix, so we would just fill in 1, 0, 1, 0, 0, 1.
Good. Yep. So L can be this lower triangular matrix, and in this case, that happens to be okay to be a diagonal matrix, specifically the identity. You guys see that? So the answer to what's U in A equals LU, well, the answer to that guy is just it's A. right? It's already decomposed into an upper triangular matrix. And then in order to say, all right, so it's a lower triangular matrix times an upper triangular matrix, the lower triangular matrix is just the identity. Another way you could think about this is if I had to eliminate here, right, if I was doing elimination steps to this thing to get to that upper triangular, well, I'd be multiplying by elimination matrices that would target, well, they target this and target this and target this. But they're already zero, so I don't need to target anything. You guys kind of with me on that? All right. How about for kind of question 2 here? What's the new U in LDU? Well, D is supposed to be the diagonal pivot matrix. So what are the pivots here for my matrix A?
2, 3, and 7.
Good. So I'm thinking, all right, so I don't know what the hell L's going to be, right? But I'm sure that my pivot matrix is going to have 2, 3, 7 on the diagonal. You guys see that? I suspect that this thing's going to be the identity again. Why do I think that? What's going to happen when you take a diagonal matrix and then multiply it by an upper triangular matrix?
What was the question?
If I take a diagonal matrix and multiply by an upper triangular matrix, what is the result going to be?
It basically just
Upper triangular matrix.
Yeah, it's going to be upper triangular. It's going to be a different upper triangular matrix, right? But at the very least, it's going to be upper triangular. You guys see that? So because I know that my matrix A is upper triangular, I have this sneaking suspicion that the lower triangular part of any one of these decompositions is going to be the identity matrix. Now, the trick, the thing I need to figure out is what goes in here. So I want to think about A as this diagonal matrix times some other matrix here. I'm going to call that matrix U. Right? You guys with me? It's going to be upper triangular. I'm not really sure what it is. There are two approaches for me to go find this thing. What is one of them? If you want to go find this matrix, right? What I want to see is I want to see that over here, so I should have my, oh, whoops, come here. So I should have my diagonal matrix. And then I'm going to take that diagonal matrix, I'm going to multiply by something, and I'm supposed to wind up with this.
Wouldn't you just divide the diagonal piece to the row that it corresponds to? So like 2 would divide from 2, 4, 8.
Oh, that's interesting.
And 3 would divide 3 and 9.
Yeah, you could notice that when you multiply by a diagonal matrix, right? What that's going to do is it's going to multiply that whole row by 2. Is that true? Let's see, so if I pick up the first column and drop it on, I'll get 2 times the top entry. If I pick up the second column and drop it on, I'll get 2 times the top entry. Oh yeah, that seems like it works. You guys see that? So Jacob's saying you could notice that this will work. What's your middle row going to be?
0, 1, 3,
Good. And your last row?
0, 0, 1.
Cool. And so my LDU decomposition for my matrix A is these two guys are D and U, and the L is the identity matrix. So this is L, D, U equals A. Does that kind of make sense?
Yeah.
So what was the answer here? They were asking what's the new U? Which one of these is the new U? Which one's labeled
One you have labeled U.
Yeah, the one labeled U. Okay, now does it make sense that they wouldn't be the same, right? This U for part A in the LU decomposition, that U is different than the U in the LDU decomposition. Does that kind of make sense? When would I expect these two U's to be the same?
If D was just the identity matrix.
Good. If D was the identity matrix, which would, and remember D is the pivots, right? So if the matrix had pivots that were all ones, then I would expect the two U's to be the same. Does that kind of make sense? Okay, cool. Hearing no objection. Anything else on this set of topics here? Okay.